again for coming. Thank you for coming to our lectures and planning series. Today we have Professor Seth Spielman giving a talk on local knowledge and digital representations of social space. Seth is an associate professor of geography and information science, and also the assistant vice chancellor of data science and strategy at the University of Colorado. His expertise is in maps, statistics, and machine learning. Recently, he won the Breheny Prize for the best paper in environment and planning, a Kaggle.com data science competition, which is a big deal, and was awarded a Distinguished Scholar Award in Planning from the American Association of Geographers. The journal Science wrote a profile of him as an archetype of a new generation of data-centric geographers. Seth's publications have appeared in a diverse set of journals, including PNAS, +1, Demography, Annals of the Association of American Geographers, and the International Journal of GIS. Outside of academia, his professional experience has ranged from the hyper-digital world of data science and software engineering from a large tech company in Silicon Valley, i.e. Apple, to the insanely analog practice of being the sole proprietor of an antiquarian bookshop in Manhattan. Did not know about you. And in addition, I will just editorialize that he is the distinguished co-author of Urban Analytics, a compendium of contemporary issues and methods in urban data science, along with Alex Singleton and David Fulch. So with that, I will hand it over to you, Seth.
Thanks. And I am a graduate of this program a long time ago, and I was also born and raised on the corner of 116th and Amsterdam, and so it's weird being back here. What I'm going to talk about today is a little bit different from what I said I was going to talk about. Maybe. There we go. I'm going to talk about how we represent the social landscapes of cities digitally, and how we reason with those, and some challenges around that. I was going to talk a little bit about some experiments that we've done with planners on how they use data, and I can talk about that if people are interested. I just sort of changed my mind. This talk is a little bit I have this bag of canned talks that I do all the time, and this is not one of them. So I'm trying out some ideas on you, and I'm hoping that we can just, given just the nature of the audience and that this is informal, that we can just have a conversation about them. And so feel free to call me stupid or interrupt or ask a question or whatever. I'm interested in what I'm calling digital models of social space. What I mean by that are the ways in which we represent the sort of social and economic landscape of cities in computers and on maps or in data science. So there's been this kind of revolution in data technologies in terms of how we collect data, how we store it, how we transmit it, how we analyze it. And this revolution gives us lots and lots of data about cities, and I just am coming off of kind of 5 years working at Apple, dealing with these very massive collections of data that you can get from, say, people's phones and things like that. But I think that for urban scientists or urban social scientists, a lot of this new kind of data is just not very interesting, because you know a phone was somewhere, you know a taxi cab was somewhere, but you don't really know anything about the people in it, right, or their characteristics. Sometimes people refer to this new data as sort of long but thin. That is, you have lots of records, but you don't know much about the people. So for me, as a social scientist, this data is not super interesting. But I also think that as planners and social scientists, we're still basically using Model Ts. That is, we're using a kind of data infrastructure that was invented at the turn of the last century. And there's significant opportunity for innovation in how we represent the social landscape. And I'll try to argue that, or I'll show you that kind of what we're doing today, for the most part, is a progressive era innovation. And I'll argue that there are some problems with that, with the system that we're using. And then I'll share some kind of new insights as a result of this critique, some kind of new insights into the structure of urban space, And then I'll present what I see as a kind of central tension in rethinking how we might represent social landscapes in new ways. And I might not get to all of that, because that's a lot, and we'll just see how it goes. So this I thought I'd start with this. This is a census enumeration form from the 1910 census. So every 10 years, every 0 year, since 1790 in the United States, we've done this a decennial census. The questions on the census have changed. The census has always been a very political thing. It's very political now. It's coming up in April. But this is what the data, for most of its existence, the data from the census looked like. It's just lists of names and characteristics of people. And around the turn of the last century, 1906, 1907, this guy, Walter Laidlaw, who was a Presbyterian minister who did like anti-poverty work in New York, he kind of got annoyed because the data that came out of the census didn't allow him to identify populations in need. It didn't allow him to measure the impact of his work over time. He couldn't see change. Like, am I actually reducing poverty? Am I doing anything? How many people do I need to reach out to? And so he was annoyed that the way the data from these lists was compiled didn't allow him to do the kinds of things that he wanted to do as a sort of progressive do-gooder. So he came up with an idea. And this is kind of his idea. This is just like a stolen Google air photo of like somewhere in Kansas. But Walter Laidlaw's idea was rooted in the Homestead Act. That is, at the time, the western United States had been divided up into grid cells. And people could go homestead on those grid cells, a little square piece of land and claim it for their own. And Laidlaw had the idea that we should do the exact same thing, that we should cut American cities up into grid cells, and we should just count up these forms using grid cells. And so we'll have this fixed grid cell, and we'll just get counts of people over time, and we can look at change. And it's a pretty simple idea, but logistically really hard in an era of no computers, right? And like there were some like machines made, but he made these maps. He did this by hand for the most part, and like bankrupted himself in the process. But this is an example of a map that Walter Laidlaw made. These are those grid cells applied to New York City. This is right around 1920. So this is death by tuberculosis in New York in 1920, and you can see his system, and you can see how he's representing kind of tuberculosis deaths using something like that grid system. Laidlaw's idea was kind of interesting because he did it not just for the 1910 census, but also for the 1920 census. And so that allowed him to do things like this. So this is one of Laidlaw's maps, and it's kind of hard to see here, but if you zoom in, so the circles are areas that lost population between 1910 and 1920. The hatched areas are areas that gained population between 1910 and 1920. And so what this map shows you is the emptying out of the tenement districts of New York and the growth of the outer boroughs in that period. And this kind of representation wasn't possible before Laidlaw had his idea. So the New York Times wrote a review of this book on April 1st, 1923, and they liked it. His book was called Statistical Sources for Studies of the Greater New York Area, some really boring title, and it's kind of surprising that it was reviewed in the New York Times, but it was. This is the title of the book review, and either this is an April Fool's joke or a typo, or he's satanic. It says New York's Doomsday Book or Demonography. I'm not sure if demonography is a thing. But in their review, they said things like, cities like tissues should be placed under the microscope. It was thus that aircraft plotted the enemy lines. The small square unit was the guide for artillery and every other purpose. The small square unit is what the social, the religious, and the civic worker need today. He can then direct his artillery precisely where evils need to be bombarded and can so secure for the good a guarantee of rapid development. So people liked it, right? And there's a lot of like, we're making the world a better place through little squares on maps. So the interesting thing to me, and like slightly perplexing, I think, if you stop to think about it, is that Laidlaw's idea is exactly what we do today. Like, it is 100 years later. There have been revolutions in data, in computing, in science, in everything. But like, this is from, I think this might be 2015 data, but this is a map, and people have seen maps like this before, maybe even made maps like this before. This is data from the US Census Bureau. This is showing the percentage of kids under 18 in New York who are in poverty. So we're doing the exact same thing that Walter Laidlaw did today. And I think there are opportunities to challenge that and to think differently about how we represent social landscapes. Just to make it clear what we're doing, this is just a kid on a wall. This happens to be my kid, not my wall. When we use census data, we're taking those disaggregate responses of people, right, and we're grouping them together into areas. And when we do that, we're kind of blurring the picture. Right here, I'm just taking the individual pixels from this photo and grouping them together, and you can see that the resulting picture gets kind of blurry, right? And this is what we're doing when we use Laidlaw's system, right? We're getting a blurrier picture of the social landscape of cities. Similarly, we could group them differently, and we end up with a different sort of picture, right? But when we reason with maps that look like this, we're reasoning with this fuzzy thing. But we don't really know how fuzzy, and we don't really understand the nature of the fuzzy thing, because for 100 years, this is all that we've ever had. So, in the US and kind of around the world, cities have been divided up like jigsaw puzzle pieces into these statistical geographies. And these puzzle pieces are used to aggregate people or survey responses. And this aggregation sort of affects, we know that it affects our view of the world, but we don't even know exactly how it affects our view of the world. Now, but this choice, this way of representing things, was not the only choice that could have been made. There were other possible ways to represent urban social landscapes. And in fact, around the same time that Walter Laidlaw was proposing his grid system, Charles Booth in London was paying people to walk around and classify streets in London. People seeing Booth's maps like they're hyper detailed. And rather than using areas, these are almost building by building, sort of street by street. And he's not tabulating data like this is a little, it's London, right? So it's like very class-based. So like they're grouping dwellings into, or the people who live in dwellings into classes. So for example, these, the black buildings up here, right? These contain the lowest class vicious semi-criminals. And on the high street here, on the sort of Whitechapel High Street, here we have middle-class, well-to-do people. But like the other thing that's kind of interesting in looking at these maps is just how diverse, just sort of how mixed together. We have like vicious semi-criminals right next to reasonably well-off people. And you couldn't, if that existed in New York in 1910, you couldn't have observed that, right, in Laidlaw's system. So Laidlaw's, this idea of cutting cities up into these little square pieces was not universally accepted at the time. Like there was some pushback against this idea. So this is a quote from an article in the American Sociological Review, and this is a debate between this guy Quinn and a woman named Allian, and I forget their first names, but Allian had this complaint about the use of census tracts to do sciencey stuff. And her complaint was that cities are dynamic. They're continuously variable, right? That is, cities aren't little jigsaw puzzle pieces, right? It's this landscape with gradients and ebbs and flows. And so Quinn is responding to her critique and he says that the contention by Allian that a gradual gradient makes impossible the existence of zones does not seem valid. In the field of physics, for example, the gradual change in the length of light rays throughout the rainbow spectrum may be taken as an example of a gradient. Nevertheless, distinct zones of red, yellow, and blue appear in the rainbow, even though no sharp line of demarcation can be drawn between them. It seems possible, therefore, for distinct zones to appear even where gradients unquestionably exist. Right? So he's arguing that even though cities are continually varying, like a rainbow, you can still have these distinct zones within them, and that zonal system isn't bad. Allian's other critique, which he sort of concedes, is that, well, there might be different zones for different purposes, right? Like maybe the zones for studying poverty or transportation are not the same. And this system that we have just implies this rigid grid for all things. So my point only is that there were alternatives and there was debate, but it kind of fell away. And in the US and lots of other countries, we use this Laidlaw grid-like system to describe the social landscape of cities. Well, so, everybody with me? Questions? So, the next bit that I want to talk about is, like, so what? Like, how does the use of this system affect the way in which we understand cities? And I'm going to do that by looking at two sources of data that I have had sort of privileged access to. I'm going to be talking about the decennial census and something called the American Community Survey. Are people familiar with those? American Community Survey, everybody know about? Okay. So I think these two data sources are among the most important data sources, kind of, at least in the US. These together sort of shape our democracy in that, you know, the decennial census is used to apportion the House, but also massive amounts of money is allocated based upon these data sets. Somewhere between 4 and 600 billion, depending on who you ask. It's a really significant portion of all discretionary federal spending are directed to communities based upon these data sets. And the ACS is the largest survey in the US, by far. This is what the decennial census looks like today. It's different from those paper lists. So every house in the US has what's called a map ID. This is from the master address file. And this is not real data. This is totally made up data. And then you have information about each person. People have a person ID in the census. It's like a social security number, but not. And then you get information about age, race, gender, home ownership. You get a limited amount of information about everybody from the decennial census. So the decennial census covers every single house in the United States and gives you this person-level data at a particular point in time. And I worked with the Census Bureau on stuff, and we were granted access to the raw decennial file. So we had this map of every single person in the United States in the years 2000 and 2010. And we wanted to understand how these representational choices that we make in terms of cities affect kind of the view of the world. So one of the things that we did is, so we had something that looked like this, right? So we had information about every dot on here. Again, fake data, not the real thing. The real thing is very controlled. We had information about every single person here, and then we had this system of census tracts. So one of the things we wanted to know, very simply, is if we take a person and we look at the characteristics of their census tract, and then we draw a different geography around them, a different shape. In this case, a shape, a circle, that contains the exact same number of people as their census tract did. And we look at whatever statistics we can get out of the census, which aren't many, like race and basically race. Do we see a difference? And what does that difference look like? So this is the resulting map. So this is the difference between an egocentric measure, that circle around a person, and a tract-based measure of the percentage of the population that is African American. So these dark areas are essentially no change between the two measures. So we're going to know why it's dark. There's no, like, yeah, it's entirely white. Like, you can draw any circle you want. There are no black people in, like, or not a lot, in rural Montana, not none, or Wyoming. I live in this part of the world now, so. But in other places, subtle shifts to the boundaries, and these are fairly subtle shifts to the boundaries, can actually really change the composition of the resulting area, right? So we're seeing changes in up to 25% in, sort of the Mississippi Delta region, and other parts of the South, just by changing the boundaries. Right, so the landscape is changing significantly. And this is a little bit of a simplification here, but I can point you to the paper. This is a published paper on this, and you can sort of read the details. So this should be surprising. This is sort of surprising, right? Because our picture of neighborhood composition changes dramatically when we change the boundaries. But it also shouldn't be all that surprising, because if you kind of, read words or listen to sounds in this country, you have heard conversations about gerrymandering and kind of the impact that gerrymandering has had on our political system, right? And so all that we're doing is demonstrating that gerrymandering, in fact, is a real thing, right? We're just showing it with this data set where people couldn't have seen it before. So by changing the boundaries, we're sort of changing the picture of reality with the census data. So I'm going to skip this just in the interest of time. We did a very big gerrymandering exercise, and I'm going to skip ahead to something else. So we did other forms of gerrymandering and showed that, for example, the relative amount of segregation that you observe in a city can change dramatically. So if you can look at the most segregated city in the United States, do some gerrymandering and make it not the most segregated city in the United States anymore. If that makes sense. So you can sort of reorder cities in terms of the amount of segregation that they have. Segregation is not an absolute thing. It's a functioning part of the boundaries, is what we're saying. Another thing that we did with this data set, this map of kind of everybody in the US, is we brought in data from the American Community Survey. So the American Community Survey contacts about 3.5 million households in the United States each year. Only about 2 million respond, so about a 60% respond, 60-something% response rate. But it collects super detailed information about each person, each household that responds. So unlike the census, which gets your name, it does get your name, but age, race, gender, and things like that, the ACS gets your age, race, gender, how much money you make, how much education you've had, how long you've lived in your house, how big your house is, all sorts of data about you. So the decennial census gives us 100% coverage, but the ACS gives us very sparse coverage, right? It's something like a 1 or 2% sample in a given year. So this is, I was trying to I got kind of tired and lost count of how many red dots I placed, but the ratio of census observations to ACS observations is even more extreme than this, right? So the ACS is kind of rare. But for this house, we know lots and lots and lots of stuff about the people who live in it. So one of the things we did with this map of everybody in the United States to try to understand these aggregation effects is, rather than just gerrymandering, we picked households based upon the sort of income and race of the householder, the person who responded to the form. So for example, we would pick the blue dot for all high-income whites in Minneapolis. And then we would go door to door to their neighbors. We'd look at the house next door, the house next door to that, the house next door to that. We were doing this based on straight line distance, so it's kind of like a spiral outward from the home, if that makes sense. So we had this like door-to-door, neighbor-to-neighbor kind of thing where we were sort of growing this area around every single ACS respondent in a given racial and income category in a city. It's kind of like we're pouring water on them, making these puddles that got bigger and bigger and bigger, if that makes sense. So what that let us do is it let us have an origin point that we knew something about, and then we could measure the racial composition of the neighbors of that person. And we could only measure racial composition because we're dealing with the decennial census. It doesn't have much information in it. But we could go door to door and look at, you know, of your 10 nearest neighbors, what percentage are white? What percentage are black? What percentage are Hispanic or Asian or whatever? Does that make sense? So we end up with this graph for each person that looks something like this, where it's the composition of the population as a function of distance. So out here we have 10,000 neighbors, right? And over here we have 1 or 2 or 3. Now we couldn't publish people's individual curves, but we could average them for a city. And I'll show you what that looks like. So here we're taking low-income ACS respondents in Detroit, Michigan. So this is their home at 0, and this is their 10,000th neighbor. Apologies for the qualities of the graph. There's a whole story there about computing infrastructure in the secret room where you have access to this data. And so I know this is kind of hard to see, but so the person's immediate neighbors are right here, and then at 10,000 people, we're out here. These are low-income ACS respondents in Detroit, Michigan, and these are African-American respondents, and these are white respondents. So what this graph shows us is that low-income whites in Detroit live in neighborhoods that are 80% white. And low-income African-Americans in Detroit live in neighborhoods that are 80% black, about 20% white, and kind of Hispanics and Asians are not really a measurable portion of the population for people. Does that make sense? Now we're looking at middle-income ACS respondents in Detroit. And we see that if you look over here at the low-income whites, you can see that middle-income whites live in areas that are even more white than low-income whites, and here, African Americans live in places that are less black and more white. If we look at these two things, do you see how these two lines are kind of moving closer together as we move up the income ladder in Detroit? And that white line is just moving up. So if you look at high-income blacks in Detroit, they're living in neighborhoods that are 60% black and 40% white. And if we look at high-income whites in Detroit, they're living in places that are about 90% white. Which, if you've read the segregation literature in the United States, shouldn't be shocking. This is not necessarily new. But here's what is new. I'm going to skip ahead. By doing this, in certain kinds of places, we see lots of action at the micro scale. So when we look at Minneapolis, so here we're looking at low-income African-American ACS respondents in Minneapolis. And if you were to look at the census, right, if you look at the census tract where these people live, you would say low-income, so census tracts have, 4 to 8,000 people, they're kind of right around here on the scale. So if you were to look at the census tract in which a person lived, you would say low-income African-Americans in Minneapolis live in neighborhoods that are about 50% white. But if you look at the micro scale, if you look at who their nearest neighbors are, it's different, right? There are these little tiny communities, within Minneapolis. Right, there's this kind of microstructure that gets lost in that macro pattern, in that Laidlaw approach. Does that make sense? Sorry, I'm zooming in. They control the resolution of the image and what software you can use, and because they're worried about disclosures. So this is just saying what I already said, right? That we're seeing these kind of micro neighborhoods that were not visible and have never been visible in the aggregate census data. Here's Denver. Similar, this is again low-income African Americans in Denver. Crazy diversity. It's 30% Hispanic, 30% white, and 30% African American at the micro scale. But as you move out, you end up with a different composition. Yeah.
When you say micro scale, how many neighbors are we talking about on the x-axis there?
I think, So I'm gonna have to eyeball it. You know, but like less than 100, I would say. Less than 100 nearest neighbors. Got it. Right? And actually, I would argue that, I think this is actually, as we'll get to, I think this is actually occurring sub-block. Like this is smaller than a city block, these kinds of things.
Is this only single-family homes, or is this also comprised?
This is anybody who completed the census in 2010. So the initial seed points are anybody who was sampled and filled out the ACS. And then we're looking at every person who completed the census. And so that's not 100% of people, but it's like more than 95%, 98%, something like that. It's among the best, most comprehensive sources of data. So we're seeing this kind of hyper-diverse, this interesting stuff going on that we just can't observe normally. And it like smacks of Laidlaw, right? At least to me, right? These maps of London in 1890, you know, where you have these very these micro-scale patterns, right? Like there's evidence of that today or 10 years ago in American cities. So I think that there are these kinds of microstructures in American cities, and the Laidlaw system, the grid system, doesn't allow us to understand that. So here, I don't know, let's pretend this is years of post-secondary education or something like that. This is some data. Here we have individual people represented by numbers. In the Laidlaw system, we would only know that this whole area was averaged 2.5. In this aggregate thing, we can see, or we can begin to glimpse at these patterns that exist underneath that. I think that, you know, if you I think that sort of planning and the sociological literature make a strong case for the fact that streets structure urban space, right? Like, you know, Jane Jacobs or Lynch or Rick Granis in sociology all make arguments about how streets structure the experience. That is, people on facing sides of the same block, like these two people are more likely to be similar, or these two households are more likely to be similar than this house and the one on the back of the block. Because that's how sort of social interactions occur, and that's how housing works. Maybe. It's a hypothesis. So one of the things we've tried to do is to figure out if that's the case, to see if streets structure urban space more than blocks. If that makes sense, that is, do we see, so let's take, so right now data is published, you can get data from the decennial census at the block form, and you know, we could have two blocks that have 35% home ownership. Both of these would appear identical in the census, but in one, we have one street with 100% home ownership, and 3 streets with 0% home ownership. And in another situation, homeowners are sort of mixed within. Does that make sense? So the question is, which one of these is more common? Like, are we getting similarity along the street network, or no? And here, I don't know that we have a good answer. So what we've done is we've done a kind of pseudo-hypothesis test of the idea that streets structure urban space. And so we have we've taken a real city, or a bunch of real cities, looked at their actual composition and measured the difference between the composition of each street, of each sort of block face, and the block as a whole, right? So if this was 35% ownership rate, and that street was 100% home ownership rate, we would measure that difference. So in this case of a clustered pattern, and this gets a little data science-y and geeky, and so I'll go right. In the case of a clustered pattern, what we're doing is we're maximizing the difference between the composition of the block and the composition of the streets. If that makes sense. And in a case of mixing, that difference is minimized. And so we've done these hypothesis tests. What we're trying to understand is the average difference between street and block composition larger in the real world or in these sort of shuffled fake cities where we're randomly assigning I'm losing people. I'm going to shut up and move on. Okay, so we want to know, are social attributes concentrated on streets or are they evenly mixed within blocks? Does that question make sense? Because we saw this evidence from that other thing with those graphs that there was like this micro stuff going on. And what we see is almost across the board, with a few examples, across the data that we could get from the census, that there seems to be structure there. That in almost every case, the block, and this is still a little squishy and not quite fully baked, but we think that in every case, 0 meaning these are, I don't want to get into it, but 0 meaning we believe all these zeros, all these green things, are cases where we believe there is more structure on that attributes are structured at the street level, not randomly mixed within the block. If that makes sense. The only thing that is randomly mixed within the block is in Houston, the percentage of females living with roommates seems to be pretty random. But everything else, for the most part, seems to be kind of clustered along block faces. So that means, for example, average age, meaning that the average age in Los Angeles, that different sides of blocks in Los Angeles there's evidence that across the city as a whole, there's differences in the age structure of populations at the block scale. And again, not peer-reviewed, still in the oven to some extent, but it's kind of whatever it was.
I have a quick question.
Yeah.
Does this, I noticed that these are all kind of larger metropolitan areas, and obviously the street face and the census block is going, there's a scale issue where kind of in more rural
Yes.
areas you're going to have.
Yeah.
But does that make,
And even like between LA and say New York or other places or Houston.
does that geographic scale, the different size census block, have make an impact on these neighborhoods?
We
Or
think
is it kind of scale?
we think it does. We think that, and this is where it gets kind of complicated. Like, let's.
I don't want to
Yeah, it gets kind of complicated, but yes, it's a good point, and yes, and like afterwards we can talk about it, but it gets kind of complicated. It has to do with it impacts. So you can imagine something rare that was evenly distributed across the space, like where there was an equal probability anywhere in the city, and then you could imagine something that was rare but just concentrated locally. And so we've done some simulations of different kinds of situations to try to understand if this is actually true or not, and we're working on it. So, I guess to wrap up a little bit, I think there's this paradox. So I've been arguing that there's this microstructure in American cities that we haven't been able to see for the last 100 years because of how we publish data about the social and economic landscape of cities. And this sort of begs the question of like, well, if we could zoom in, we could see more and do more, right? We could understand cities better. But I think there's this important trade-off between sort of geographic resolution, demographic resolution, and privacy that we have to keep in mind. So here we're looking at, So here we're looking at, this is again that same map of New York. These are those laid lot areas. And kind of behind the scenes of this map, so for every one of these places we get a number. It'll say, in this case, say 30% of kids are in poverty. In addition, because these come out of the American Community Survey, which is that sparse survey, we're not talking to everybody. We're just talking to 1 or 2% of the population in a given year. All of these numbers have a margin of error associated with them. How many people are familiar with that idea? So if we look at the margin of error in the ACS, in the data that we use to make maps like this, we see that the margin of error is generally ginormous. So here, this is a slightly different variable. This is the number of percent. This is the count of kids under 6 below the poverty line. And these are the census tracts in New York. So in this particular census tract, there are 105 kids in poverty, plus or minus 106. There are 40 in poverty, plus or minus 60, 139 plus or minus 90. So like these data tell us that somewhere between 0 and a lot of kids live in poverty in a place. And so these data, aside from the fact that they're problematic because they hide things, they're also problematic because the quality of the estimates that they yield is less than super awesome. So this is all census tracts in the United States. This red line is a margin of error that is 100% of the estimate. So 100 kids plus or minus 100 kids. What we see is that in about 45% of all census tracts, the margin of error on estimates of childhood poverty are greater than the estimate itself. Right? So it's that 90 kids plus or minus 106 in about half of all neighborhoods in the US. In the remaining half of all neighborhoods in the US, the margin of error is 50% or more of the estimate. So 100 kids plus or minus 50. So for these like policy relevant, really meaningful variables, we have these huge margins of error. This is data that measures the percentage of the population that is low or moderate income. This LMI number, it's called, is used by the Community Development Block Grant Program to determine if communities are eligible to receive money under this federal program, and it's billions of dollars. This point, so this red line is 51%. So if you're above the red line, you qualify, and if you're below the red line, you don't qualify. Each point here is a town in Washington State. There was a lawsuit in Washington State, which is why it's Washington State. But each point here is a town in Washington State, and then the bar coming out of it is the margin of error. So how do you give out money? How do you use these data to give out money when, if you take the margin of error into account, everybody wins? What do you think we do now as a country? Anyone have an idea? Yeah, we totally. So the official policy is that the margin of error does not provide an expanded range for compliance. So this is the HUD policy around the CDBG program. Like, it doesn't matter. If you are, it says here, I blocked it a little bit, but it says a service area of 50% lower moderate income with a 2% margin of error would just be 50% lower moderate income for compliance purposes. So we're giving out all of this money, we're using this data to do all of these allocations, but it's like deeply flawed. Aside from the fact that it's hiding all the micro stuff, it's deeply flawed.
Is that because the sampling is so expensive? It's only 1% sampling? It should be 10% maybe.
It used to be a lot more. So that's exactly, yeah. So here, this is the 2000 decennial census. And so this is how many completed, what used to be called long form, how many completed surveys you have per census tract. So in 1990, you had 243. In 2000, you had 249. You have about half the amount of data going into your estimate now that you did when these practices emerged, right? So modern practice around the use of data for planning and governance emerged at a time when the data was very different. And this is totally just lack of investment, right? If we spent twice as much money, we could have twice as many completed forms, right? The ACS is not funded to hit a certain response rate target. It's just given an allocation of money, and they get as many responses as they can for the amount of money that they have. So the problem with things like the ACS is that as you zoom in, you get fewer and fewer of these blue dots. Right? Does that make sense? So there's this paradox about, like, you want to zoom in and you want to zoom in to capture all this microgeographic detail that I'm arguing is there, But when you do that, you dilute your samples and you get stuck in this trap, right? Which is sort of, I think, a little bit of a paradox. Like we live in a world where you think of like zooming in on Google Maps and you can see more stuff, and you can see more detail, and you can pop into Street View, and you can get all of these things. But with data about the social and economic landscape, that's not the case. It's like you zoom in and everything gets fuzzy, like everything gets blurry. Because you don't have samples. And you zoom out and you get a more precise picture because you have lots and lots of samples, if that makes sense. So you get stuck in this trap where it's like, on the one hand, I'm arguing, like, there's all this stuff going on that would be great to see, but we can't really see it because of the design of the survey. And so the answer to this is maybe big data, right? That is, the world has changed in terms of, like it used to be in 1910, the Census Bureau was like the game of town, but it's no longer the game of town, right? There are all of these other forms of information. However, I would argue, and this, Derek Ruths and Pfeffer, this is from Science a few years ago, argue that, all of these new forms of data are actually not that useful for principled social scientific inquiry, or for planning, or for allocation, or for really doing anything with. So they would say that, yeah, you get from social media or other forms of organic data, or other things that I think of as sort of new urban data, these new sources of data that aren't the official statistical systems. So we get data about individual people. It's really disaggregated. So we can maybe aggregate it how we want, and we can solve that micro problem potentially. But Ruths and Pfeffer would argue that there are like deep selection problems with the data that you get from organic systems that, unlike the census where everybody has to respond, and if you don't respond, somebody comes and somebody calls you, and then somebody knocks on your door to make you fill out the form. You use Instagram or you don't. You use Facebook or you don't. You use Twitter or you don't. And in fact, Instagram users are different, demographically different and economically different from Facebook users and from Twitter users. And so while you have all of these organic forms of data, they don't actually really tell you a lot about the they tell you about the users of the platform, but not about the population. Ruths and Pfeffer would also argue that these systems create distortions of human behavior. That is, unlike the ACS where we're asking questions to design the instrument, on social media platforms, the only kinds of behavior that are observable are the kinds of behavior that the platform allows. Right? You can only do what it lets you do. And so you end up with these kinds of distortions of behavior. That these are maybe not helping you see the social world in a meaningful way. And then they make this argument about clubs, which resonates for anyone who has a friend who has this awesome data set that you can't get. What I mean by clubs is, if you have a friend that works at Google, maybe you can get some data from Google. But if you don't, you can't. And that raises questions about replicability, the use of these data for policy, for science, for governance, and things like that. And so while, it just feels like there's this trap, right? There's like this data that exists, it's micro, we want to look at micro stuff, I'm arguing there are micro patterns, I don't know how to get at the data because, so that's kind of not a very good conclusion. I think for urban data science, for urban data science to be a socially and scientifically meaningful enterprise, for data to actually, for the use of urban data to have an impact, a positive impact on people's lives, we need accurate, meaningful, and useful representations of the urban demographic and economic landscape. And I'd argue that we're in this weird place where we're swimming in data, but we don't have really good representations of the social landscape. I was able to peek at it through access to this sort of secret data, but you're very limited in what you can do with that, and I don't really know the answer.
We have about 15 minutes, 20 minutes for questions. Does anyone have any questions I would like?
How does a single family home in Queens, how do you buck that with the immigrants? How do you tell, how do you differentiate between fraud and the accurate reading?
Yeah.
Because they're knocking, it's all on paper pretty much, right?
Well, now it's a lot of it online in 2020. It's a real issue. I mean, there was some canvassing that they do. They do some actual canvassing on the street to generate the lists. But it's a big issue, and it's political now. Like, there's a deliberate effort to kind of scare immigrants and to get them not to respond. Yeah.
So, has there been any study that you know of into like what the dollar return value of the ACS is? Because I imagine it'd be hard to calculate, but also probably
It's a great question.
considerable. And then also, do any organizations exist that try to lobby Congress for a larger budget for ACS?
Yes and yes. So a lot of my work was funded by the National Science Foundation. At the same time, two economists, a guy named Chuck Mansky and I'm blanking on the other guy's name, from Chicago, were given a grant to do exactly the question that you asked. What is the value of these public surveys, and how do you sort of calculate the value? Thinking that this would be a useful lobbying thing. And I don't know, I never saw anything. And they kind of dropped off.
How long ago?
6 years ago. Yeah. So that, but yes, there are groups that lobby for these things. Yeah.
Two questions. The first one is about this microstructure you showed us about how maybe dynamics within neighborhoods are not the way we thought it is. In terms of broad urban policy, how to accommodate these specific scale into larger
Yeah. Yeah.
And the second question is, if we take into account all the hindrances that APACS currently has, we can come up with data with better quality, but can we come up with different questions for that data, or it will only give us better answers to the questions we already asked?
So to your first question about what is the impact of this on urban policy, the potential impact on urban policy, two things. One is, my original title was about local knowledge and blah blah something, and we did some experiments to try to understand that question. That is, like, for people who know a place intimately, like, how does the data affect your decision? And so, we do think that local knowledge trumps data, but in the absence of that local knowledge, data wins. From a policy perspective, it also means that there's just like unobserved inequality and poverty, right? Like there are these places that seem, relatively well off, but there could be these little pockets, and like you've probably experienced them at some point where you end up like around some weird corner, and like, it's just a different landscape, and it's not big, but it's just there. We looked at, there's a famous study in Chicago called the Project on Human Development in Chicago Neighborhoods. And we looked a little bit at that, and there you also see evidence that like signs of, they looked at, this is the broken windows, all the sort of broken windows theories and stuff came out of that paper, out of that work. And there you see evidence that a lot of the signs of disorder are actually geographically very concentrated too. And so, like, there's multiple things that suggest that these things are getting lost in the data, and unless you know the place, you don't see them. And if you tie federal eligibility to funds to these area level measures, you're maybe missing things, I guess is what I would say. Yeah.
I was going to say, just like, we're not solely basing our decision making on this data and on this map. So like even those federal funds, like there are, I'm not saying these systems are great, but there are systems in place where you apply for these funds and where people with local knowledge of certain areas are like advocating
it depends on the funding mechanism.
Right.
It depends on the funding mechanism. A lot of the big federal funding mechanisms have eligibility criteria where if you think the data is wrong, you are allowed to appeal it, but you have to fund a study and convince them that the study is valid. So if you're a low income under resource community, you can like hire some statisticians and do a thing. I have friends in Portland who have done that for places. So, but yeah.
Oh, sure, I was going to ask you a question.
Okay.
Oh, sorry. Me, okay. As cities sort of start to, as places start to urbanize and people start to live more and more densely, is there any sense of urgency around, like things you talked about, like shrinking, maybe perhaps shrinking census tracts or looking, concentrating more at block level where there will be more people living, and analyzing from, instead of looking at census tracts, looking at smaller units?
Yeah. No, in fact, the movement is in the opposite direction. And so the movement now within the federal statistical agencies is towards implementing something called differential privacy, which is interesting, but it's essentially, the argument is that there's so much data available now that things that were innocuous data releases from the Census Bureau could now be used to identify you. And so there's a move to release less detailed data and to inject like statistical noise into the data so that it's harder for people to like hack the data to find you. And so for the 2020 census, it's the other way. It's less detail, more noise to try to protect privacy. I think it's a mistake. I think a lot of scientists think it's a mistake. But
Is that coming from the current administration?
no, that's coming from a labor economist named John Dowd, who's the scientific director of the Census Bureau and has had a pet project for the last few years. And he's sort of convinced people that the sky is falling. And there's an open letter protesting those changes.
Are there analogs that you're working on or other people are working on to sort of think about different measures of identifying inequality, like commercial data sets or other sources that you could use to triangulate effectively?
So you used a great word, triangulate. So I think a lot of commercial sources by themselves are pretty biased, like they suffer from those bias problems and selection problems. But there's this really interesting area of research where people take the official data set and some other data set that is maybe less, that is more detailed but is less good, and then try to like triangulate from those two data sets. So, and I'm aware of a few papers that kind of try to do that. One is around language, so looking at the language that people do Google searches in to try to get at sort of ethnic composition in more detail. But the problem is access to those other data sets, and they change, and like it's hard to build these natural programs on top of things. Like Google might change how it captures data, and all of a sudden like your machine breaks. And so there is interest. There was a meeting at Facebook a year or two ago, which had like, it was interesting. It had like sort of Silicon Valley folks, as well as folks from Washington, like census directors and stuff. And it's interesting. Nothing super useful came out of it. It was fun. Like it was a good food and drink, but like not but it was in the spirit of that.
And I was actually going to ask something along those lines of how do we use these kind of newer big data sources to triangulate to more accurate measures along with kind of census
Yeah.
data, or this idea being that like maybe perhaps like the more data sources you have and the more regularly you're able to kind of calibrate these measures, which is what big data will give you, right? Somehow kind of the more accurate your measures can be. And just kind of anecdotally, when I was working at Cardo, we did use like cell phone data to try and create these like population measures, and if you compare like correlations on a tract level, it's actually okay.
Yeah.
But the biggest in
Yeah.
order to be able to adjust your models
Yeah.
to do that.
Yeah.
There's like that famous Google flu trend
Yes.
paper that talks about when the algorithm does change and your machine learning model doesn't change accordingly, then you can have bias.
Yeah. You're totally right, and so I think cell phone data, you can certainly figure out how many people are anywhere at a given moment in time in much of the world now. But you can't figure out what percentage of them are poor or have PhDs or anything like that. And that's that kind of long but like thin, like it just doesn't have that attribute stuff, which I think for a lot of policy concerns is important. And so I agree, and I think there may be interesting kinds of, like there is spooky stuff that you can do. Like, you know, if we, in the sort of surveillance economy world, right, like, okay, if you are tracking somebody over time and you know what kind of stores they go to, or where they spend their working hours, or all sorts of other things, maybe you could back your way into some of those demographic things too.
Sure.
But, yeah.
But in a sense, without worrying about privacy, like you could look at like percentage of transactions with a credit card, maybe the credit card
Yeah.
is tracked versus like Upper East Side versus the Bronx, for example.
Yeah.
But at some point.
And I looked at that, the last thing I worked on Apple was a credit card, like Apple Pay. Like, you can definitely see stuff, like there's a lot that you can learn that's interesting, but it's proprietary. Apple doesn't also track users, so we could look at areas of people. It's super interesting. It's fun, but I just don't know that it lets us get at these kinds of sciencey. It doesn't. I don't know that we would want to use those measures to allocate money or to make real policy decisions about who gets something and who doesn't, or those kind. It's hard to. Yeah, for me at least.
So the answer is just creating a data collection infrastructure that's government, one that's
Transparent at least. Whether it's government or not, it needs to be transparent. And it needs to be done in such a way that you can figure out who's not in the data.
What about these models like, what Alex has like in the UK, where they have these kind of like not third party, but they have these like data banks that are similar to census in that, the corporations can kind of deposit data here, you can access the data here, but there's somehow like a wall of privacy or transparency.
Yeah. So this is a friend of ours. The guy I wrote that urban analytics book with has got a bunch of money to build a kind of data bank for commercial data. The Consumer Research Data Center, and things like your loyalty card. When like you're in like Boots, Walgreens, like you like buy something like so like that loyalty card data or other kinds of data is in there. It's hard to link things across, but again, you can probably figure out a fair amount. But we're in like surveillance land. And then there's access, and there's who can have access, and all of those things make it interesting academically, not so much for planning practice or urban policy, I think, is my sense.
Well, sometimes proofs of concepts are important.
Yeah, no, I agree. I agree.
Does anyone else have any other questions?
Cool. Oh, sorry.
Yeah.
In this, your findings of micro level, I feel like could also make the case that a more fine-grained ethnographic or qualitative approach to data collection.
100% agree.
Yeah.
Like completely agree, and that if we lean too heavily on the like there's just all of this stuff that gets lost, and that really to understand cities you can't, at least now, but just look at data and get it. Yeah.
To what extent would you say that the conclusions that we're drawing with the way that data is collected now are questionable or invalid based on what's possible, you've shown is possible with more granular level approach?
So that was the behavioral experiment that I mentioned was we asked people to do a task. So sort of like find one of the tasks, like find the poorest part of Portland. And then we took the exact same data and so people use their local knowledge because they all lived in Portland and we have lots of agreement with people. There's not 100% agreement, but there's like maybe 3 places that people pick. Then we created a data set where it was the exact same data, but like not recognizably Portland. We just kind of like manipulated it so it didn't look like Portland anymore. And we asked people to do the exact same task. And there was a lot more heterogeneity. People's answers changed. And so I think that in the absence of local knowledge, the data matters, and when there's uncertainty in the data, when we expose the uncertainty in the data, we got lots of different kinds of answers. So, does that answer your question? Kind of? Like,
Kind of.
yeah, I mean, I think that I care deeply about the use of data and the usability of the data, and we do see some evidence that, like, decision methods change. But there's a lot more to do. Nobody really